Hello, everybody. Yeah, Catherine Monsetip here, Project Officer of MAP. Yeah, I'm really glad to be assigned as Project Officer and follow your progress over the 3 years, the project, and I can see that the results has been successful, as well as also the exploitation commercially by Beak Consulting. So I think I would like to thank you all for also for having worked really with all your effort in this project. And mainly, I would like to tell you I won't be able to participate the full meeting because I have an overlap meeting also, but I will join after the other meeting ends at 2 o'clock. Here I would like to tell you a little bit about the procedure on the final reporting of the project, as well as the continuous monitoring 5 years after the end of the project. So project coordinator has to upload a final report by 28th of February 2021. So there will be a template there available in Blue Book in the help section. And then there you will have to check various things, whether all the KPIs have been met, deliverables have been uploaded, and any success stories or anything that would contribute to show the success of the project would be uploaded as well. And I think most importantly, when the project ends, there will be also a tab in Blue Book in the project about legacy report, where you will also add how the project will be continued or exploited after the end of the project. So there's also a template for that. What else? I think basically that's the main thing. And of course, every year you will have to report if you promise, for example, if there would be some KPIs 2 years after or something. I think in MAP you don't have. And then the project coordinator will have to fill in our normal yearly reports. That is something that, or it can be assigned to some other entity as well in the consortium. So that's basically something that we need to check, and I can go through with Kalevi also at some point. So do you have anything that you would like to ask? I'm here to follow your progress on final summary or wrap up, whatever demo of the project. So yeah, that's basically what I would like to say. And okay, well, other things. If you would like to continue the project in one way or another, I wish you could also think about that for the next call, cover call 8. So actually there will be a delay call for Discover 8 for next year, as Horizon Europe will be starting, and then because the budget negotiation is still ongoing, there will be some slight change in our way of doing Discover call, because next year we will have a call over the year. So there will be several, maybe 2-3 calls, and it will be thematic wise, not only one cutoff. So there will be, let's say first cutoff will be theme, battery, or whatever. So for the woman is not yet officially launched. It will be launched by maybe the first quarter or second quarter probably. So that I will let you know. If you have idea how to continue this project or do something else related to this project or totally different, I'm happy to support you. So please do take contact with me if, for example, you need to find other consortium members or something like that. Yeah. Yes. So that's it about my presentation. A bit short, but I hope that's what it's need now at this moment. But I will anyway follow you in this discussion if you have questions.
Thanks, Catherine. we'll keep that in mind. So it's always a tempting idea to get the continuous funding, but we'll think about that. Let's go forward now with this project.
Quick addition about the next call, Kava. So the what is it? This KCA will be removed.
That's a good plus. That's a big plus. Yeah,
that's a big change.
No,
yeah.
No, okay. Yeah. Okay, well, basically, okay. So let's get forward. I'll give a very short introduction of the project itself, and then we go into the business of what we have produced. The Mineral Resources Assessment Platform project was or is still an EIT RawMaterials Java upscaling project. This has been a 3-year project. It will end at the end of this year, and the total budget was 1.85 million euros. We received 1.63 million euros EIT funding, which we are grateful for. Geological Survey of Finland has acted as the coordinator, and we have 8 other partners: Geological Surveys of Norway and Sweden, Iceland Geosurvey, Oulu Mining School of the University of Oulu, Norwegian University of Science and Technology, Beak Consultants, LTU Business, and US Geological Survey, which has acted as a supporting partner. Now, the aim of the project was to produce an upgraded method and software for quantitative assessment of undiscovered mineral resources. So the so-called 3-part method is maybe it is the most commonly used method for quantitative assessment of undiscovered resources, and it's a good method. However, there are, after having carried out assessments in Finland for 10 years, we could not help but noticing that there are certain shortcomings, mostly in the way the method is usually applied, and also in the available software. So basically, this was kind of the reason why we applied for funding for the MAP project. Now, in the application, we promised some major enhancements and additions, and we have done those. We have developed a new modular software that enables the smooth flow of the assessment process. We have implemented mineral prospectivity modeling tools for permissive tract delineation and classification. We have added an economic filter tool to evaluate the economically viable part of the total undiscovered endowment estimated. And we have added some reporting tools to ensure the standard format reporting is possible for all essential information is included in it. So the major outputs of the project, no doubt, are the software parts. So the MapWizard software, which is the freeware product of the project, and the MapWizard for advangeo 2D prediction software, which is a commercial software by Beak. Also, project partners have carried out a series of assessments during the testing phase of the software, and we are going to hear about these results later today. And the project has also, during the years, carried out or arranged a series of workshops and short courses, which have distributed information of the method and software. But after this short introduction, let's go and see the software itself. I'll start with the MapWizard freeware, and then Peggy Hilscher will then continue with the commercial version. So MapWizard is modular software that covers the whole assessment process. I'll go the process and tools quickly, through very quickly here. The assessment process begins with the selection of deposit models for the mineral deposit type being assessed. The descriptive model and the grade tonnage model tools are used to construct those models. Another component of the assessment process is the delineation of areas where geology allows the existence of deposits of a certain type. The tract delineation tool here uses mineral prospectivity modeling techniques to define these areas, so the so-called permissive tracts. In the next part of the process, we need to estimate the number of undiscovered deposits that exist in the delineated permissive tracts. This is often done by experts in a workshop, and the undiscovered deposits tool then estimates the probability distribution of the number of undiscovered deposits based on the expert estimates or some other input. The Monte Carlo simulation tool here at the bottom combines information produced by the grade and tonnage model tool and the undiscovered deposits tool, and it estimates a total in situ endowment of metals contained in the undiscovered deposits within the permissive tract. The economic filter tool, in its turn, can be used to estimate how large part of this total endowment could be economically viable to extract. And the aggregate results tool is used to combine number of deposits estimates of several tracts into one estimate, and the reporting tool then can be used to create standard format reports of the assessments of a single tract or a group of tracts. Now let's have a look at some detail of some of the tools. I don't have the time to go through all of them. This is the main starting window of the tool. On the left, then you can open an existing assessment project or create a new project. And a project is always associated with a certain deposit type, and typically a project contains several permissive tracts. The right-hand side shows the main page of an open project. All available tools are listed along the left margin of the page here. You can't probably see the texts, but these are the tools that I showed in the previous slide in kind of an order, logical order from top to bottom through that follows the flow of the process. Now the Great Tonnage Model tool. As I said earlier, the assessment process begins with a selection of construction of deposit models. The Great Tonnage Model is represented by the probability distributions of tonnages and grades of well-known deposits. And the Great Tonnage Model tool creates these probability distributions using grades and tonnages of well-known deposits as input. A close-up on the left, a close-up input. On the right, you can see the close-up input, close-up of the input window. And it's just like, you can't probably see the text, but I would just like to draw your attention to this line in here. It says select tools to be executed. And one can select either to estimate probability distributions for tonnage and grade that are independent of each other, or one can estimate a joint multivariate probability distribution that takes into account the correlation between tonnages and grades in the input data, and that's very important. The tool saves the estimated probability distributions for use by the Monte Carlo simulation tool. It also produces summary statistics and plots of the input data, and this is just an example of the output of the tool. But this slide here is here to demonstrate the difference between independent grade and tonnage probability distributions and a joint distribution. The scatter plots show simulated orogenic gold deposits as blue dots in here. Gold grade is plotted on y-axis, is plotted against or tonnage on x-axis. And the orange dots show the grade tonnage data of well-known orogenic gold deposits that was used as input to the Great Tonnage Model tool. On the left-hand side, these are the simulated deposits in blue are based on independent tonnage and grade probability distribution, so there is no correlation visible in them. Also, there is some slight correlation in the input data of grade and tonnages in here. But on the right-hand side, the simulated deposits are based on a joint multivariate grade tonnage distribution. And as you can see, the joint grade tonnage distribution produces simulated deposits that really reflect the correlation between ore tonnage and gold grade in the input data. And this is very important when doing the simulation of the metal endowment within the undiscovered deposits. The results are really different, whether you have independent or joint distributions. Sorry. Another part of the assessment process is the delineation of permissive tracts. And the tract delineation tool defines and classifies permissive tracts using mineral prospectivity modeling techniques. Two techniques are available, fuzzy logic and weights of evidence. Both can be used in tract delineation and tract classification. Now the tool produces GIS raster and vector files, but you need a separate GIS software to view those files. MapWizard does not cannot be used to view the files. This is just an example of tract delineation and classification using the tract delineation tool. The leftmost figure shows the fuzzy overlay raster created by combining magnetic analytical signal and gravity data using fuzzy OR. The figure in the middle shows the same raster with values lower than 0.4 excluded or masked. So in addition to the few large areas, there are lots of very small bits and pieces here that suggests that some editing might be needed to get the final permissive tracts. And the figure on the right shows a cleaned raster with all separate pieces smaller than 50 square kilometers removed. The MapWizard can do things like that. The raster can be then taken to represent a permissive tract, or it can be further modified. The third component of the assessment process is the estimation of the number of undiscovered deposits within the permissive tracts. The undiscovered deposits tool takes as input the estimated number of undiscovered deposits at several levels of confidence, and the tool estimates a probability distribution for the number of undiscovered deposits. It can produce a negative binomial distribution, a non-parametric empirical distribution, or a custom distribution. The tool provides summary statistics and plots of the input data and estimated probability distribution. This is just an example of the output here, but the undiscovered deposit tool then saves the probability distribution for use by the Monte Carlo simulation tool. And the Monte Carlo simulation tool in turn then produces a large set of simulated undiscovered deposits and calculates the amount of metals in these deposits. It uses as input the probability distributions of tonnages and grades produced by the grade tonnage model tool and probability distribution of the number of undiscovered deposits, which was produced by the undiscovered deposits tool. The Monte Carlo simulator produces summary statistics and plots of the undiscovered metal endowment. It also produces a file containing grade and tonnage information of all the simulated deposits. And this can be used as input in the economic filter tool. So on the left, the table of summary statistics for the amounts of several metals in the Felsik type VMS tract in Finland. Text is also too small, but it produces this kind of summary tables. On the right, univariate marginal probability density functions and corresponding cumulative frequency distributions of the amounts of metals. Now, after running the Monte Carlo simulator, we have an estimate of the total in situ endowment within the permissive tract, but we do not really know how large part of this could be economically extracted. And the economic filter tool answers this. It can be used to estimate the economically viable part of the total in situ undiscovered endowment. The tool takes as input the simulated deposits created by the Monte Carlo simulation tool, and it applies simple engineering cost models to estimate the economic resource. This is a slightly simplified version of the USGS RAF software, and it takes a number of input parameters. It's quite complicated software, and running can take from less than 20 minutes to over an hour. This economic filter tool produces a large number of output files. It's just an example of some of the output. On the left, the summary statistics showing the amount of metals in the total in situ endowment produced by the Monte Carlo simulator. And at the bottom on green, the proportion of that could be economically viable to extract. And on the right, there's a plot of cutoff grade versus or tonnage for various depths. Now, the aggregate results tool combines the number of deposits estimates of several tracts. The result can be used in estimating the total undiscovered endowment for several tracts. And finally, the reporting tool just produces simple standard format reports of assessment results. Sorry about that. For a single tract or a group of tracts. Now, just as a final word, MapWizard is freely available, publicly available. The final version was put on GitHub yesterday, so it's now available. The source code is included in the package together with technical documentation, user manual, method and data guide, and a small set of example data also. So you're all welcome to try it out and see what you could do with it. And thank you for me.
So hello everybody. My name is Peggy Hischer. I'm from the Beak company, and I'm the main programmer of our advangeo 2D 3D software. And we are, what's now? Okay. And we are developing our advangeo 2D 3D prediction software for more than 10 years now. And we can applicate the software for a mineral predictive mapping in 2D and 3D space. We can run georisk analyses with our software, like mass movements along railroads. With the software, we can process and interpret remote sensing data, for instance, for the classification or mapping of geological units or vegetation types. And we can also run time series analysis, for instance, for georisk purposes. At the moment, we have 5 machine learning algorithms implemented, artificial neural networks, random forest. This means for classification and regression applications. We have implemented self-organizing maps, weights of evidence, and fuzzy logic. And within this EIT RawMaterials map project, we've implemented the mineral assessment tool, the MapWizard, which is a standalone application within our advangeo product series. And the core is, of course, the assessment tool from the GTK that Caledonides was presenting in the last presentation. We have not included all of the tools that are available with the GTK MapWizard, but we provide now a connection to our advangeo 2D prediction software. The MapWizard itself can be started as standalone application, and it can be started from our advangeo software that we can see here. This is the main window of our advangeo software, and you can see here in the main menu an extension button where the MapWizard is included, and from this tool the MapWizard can be started. It's opened in this window, and the user can here now decide if he is opening an existing project or if he is creating a new project. We've implemented 7 modules, partly from the GTK MapWizard. This is the central window of our application. The tools are mostly independent of each other, so that the user can switch in between. A status message below the model is showing the user if there was already a calculation successful or not successful running. And we are the buttons that we can see here in the main menu. The user can switch between the different modules and this master module window. Yeah, as you already have seen in the last presentation, we can calculate the probability density function for grade and tonnage model, or for one of them. The input is at the moment a CSV file with an ID deposit and the tonnage and the grades of particular minerals. And the results are plotted as summary text and as plots, as histograms or functions within the node. For the permissive track definition, we decided to connect our MapWizard with the advangeo software. That's what we can see here. And in this track delineation tool, we have the possibility to select and to create the permissive tract via existing advangeo prediction models, or we can just select, or the user can just select existing tracked polygons for the next steps. So the connection to the advangeo models is that the user has to define an advangeo project. That's what we can see here on the right side. This is the advangeo software. The user is selecting the project, like the Northwest Ghana project. Then he is selecting a prediction model, for instance, model number 005, electromagnetic. And then automatically So he's selecting the model here in this Dropbox. Then automatically the already existing prediction results in this model are shown here in this Dropbox. And now he has the user to decide how he wants to vectorize this raster. So the prediction result is a raster image. It must be converted to a vector image by creating a binarized data set by setting a cutoff. Yeah, so the user has to know the values, the range of the raster values, so that he can define a threshold. And furthermore, he has to define a minimum area size that the permissive track should have. So the result could look like this. On the left side, we can see a prediction model as raster, which is classified here between 0 and 1 in several classes. The user has defined, in this case, the threshold with 0.8 and minimum area size, and the result is then this polygon layer with several polygons. He can use this now for the further steps, or he can afterwards recreate it by setting other thresholds or minimum areas. The next tool that we've implemented is the undiscovered deposit tool for the estimation of the number of undiscovered deposits. This is based on user parameters or parameters that the user set. It's based on predefined model, a genetic model. The user has defined tract area, median tonnage, and so on. And he has to specify the experts, meaning concerning the number of the deposits in the negative binomial tool. The results are plotted here as summary text in this plots as well, and that are the input data for the Monte Carlo simulation that is used for the creation of a set of simulations of undiscovered deposits. It's quite similar to the GTK applications. The results are plotted as well in the results tab within this main window that we can see here. Yeah, that are not separate windows that are open. Everything is kept in this main window that we can see here. And finally, the most, quite important tool is the report tool. All the results from the MapWizard that were calculated, and additional descriptions about the genetic model and the deposit are included here in the report and plotted as a file, as output. The first release of our MapWizard in advangeo is finished and it's available commercially in our company. Yeah, I just want to say thank you to all of our project partners, especially Caledonides, for their cooperation, and of course the EIT RawMaterials for their funding and support. Thank you.
Thank you, Peggy. And it's very interesting and good that we have also a commercializing partner in the project, and we also have produced a commercial product as an upscaling project should do. So that's a good thing. But we have to go forward. Now we turn into the results of various partners in using the software and doing assessments in their test areas. We start with the results of volcanogenic massive sulfide ore assessment in Skellefteå area in Sweden and in the Caledonides in Norway. Thank you.
Yeah, the testing of VMS deposit we categorize or classify to two different parts. One is focus on the Skellefteå, and the other one that's the Caledonides that my colleague Terje will present. I'm presenting this result on behalf of my colleague who are listed here, and in addition, I'm going to thank Steven, Krister, and Mark Michalski, who are contributed in this assessment directly or on the. If we're going to the Sweden, Skellefteå is one of the most well discovered or explored area in Sweden. Focus on the massive sulfide deposit. That the area of the selected area is shown in the right side, that the massive sulfide mostly are hosted by felsic volcanic rock, and sometimes in the close border with the sedimentary package, Skellefteå sedimentary rock with 1.96 to 1.86 Ga belong to the mostly Skellefteå and workforce group. The data that we use in the assessment was in addition to the geology, we use the metamorphic maps, airborne magnetic and gravity, geochemistry, and also lithogeochemistry data set from the SQ's database that contained a lot of different analysis for different elements during the ongoing or previous mapping project. In addition to the data, we considered even the knowledge on the mineralization, specifically in the Skellefteå, in terms of the relation between the mineralization with the structure, with the lithostratigraphy, ages, and the depths of the different rocks. I have listed some of the latest research focus on the Skellefteå, including Malemyr, Bauer, Dehgani-Nejad, Hittite, all that they focus on specifically on the Skellefteå district. All of this concept has been considered, and in addition, like Malemyr did some seismic to calculate the depths of the basement in the Skellefteå, or Sadeghi and Carranza focus on the spatial association of the existing VMS deposit in the Skellefteå and how they changed during the time because of the east-west shortening during the time in the less than 1.8 Ga. And finally, a 3D geological model is produced in the ProMine project, and they, in addition to the drill core and also the mining data, they produce some uncertainty model in the Skellefteå that all of those one has been considered in the assessment purpose. According to the previous one, we consider the proximity of the felsic volcanic rock come with some exploration criteria regarding what's the relation between the massive sulfide and alteration intensity, positive copper and zinc anomaly in till, and even a geological or structural evolution during the time, and the location of VMS deposit in the boundary, or what was the in general lithostratigraphic and control of the VMS deposition in Skellefteå. Then we have to focus on the reality, translate the data to the different layer. We applied the mirror system approach, was representing the source, transport, trap, and deposition based of the previous research. And here you can see the listed of the ingredients, and they are translated to the prospectivity map. Prospectivity map here is the delineation one to make easier for the expertise to see where is the highest prospective area in the entire Skellefteå. For this assessment, we divided in three different traditional division of the Skellefteå in the eastern, western, and central part. And here I'm presenting the result of some of them. You can see the tonnage and grade of the median value for the tonnage, copper, zinc, gold, and silver. And you can see the distribution of them. And also we applied the Monte Carlo simulation. This is the result for the western track. And you can see the 50% of the ore, copper, zinc, and Ag, highlighted by red, 12.7, 84, and so on. And finally, we aggregated the ore track and sum up with the total value of the ore and also the copper, zinc, and silver grade. And finally, here, even I compared this result on this project on the right side with my previous exercise that we used another approach. It was the one-level prediction and the fractal analysis. And we can see the similarity of the output of this MapWizard compared to the previous one. But some small changes is because the present data is more accurate, and after 10 years, a little bit has been changed, the database. And this is the final slide. If I conclude my talk, we are estimated the undiscovered end amount of the ore with the more than 80 million ton, of the copper with the more than 700 kiloton, and zinc with the 2,900 kiloton, and silver with close to the 4,000 ton, with the number of 52 undiscovered deposits. And even the Skellefteå is a well-explored area, but still has potential to discover several deposits with the average tonnage of more than 1,000 kiloton. Thank you.
Hello, everybody. Terje Bjerkgaard from the Geological Survey of Norway. I will continue where Martia ended. We had also, in a report on the VMS testing, we also tested VMS deposits in the Scandinavian Caledonides, both in Norway and Sweden. Just to remind you, here you see what the MapWizard consists of. Here you have all the different tools. And we had to decide on an area to do the assessment, and we decided on the central part of the Scandinavian Caledonides. It's called the Grongstekenjokk metallogenetic area, where we have probably the most data from exploration, and there also been quite a lot of mining going on. There are 4 different tracks in this area, 2 in Norway and 2 in Sweden. We have the Gjersvik, Joma in Norway, and Stekenjokk and Blåsjön in Sweden. And these tracts, they are, the good thing about them, they are different. They are of the different VMS subtypes. We have Gjersvik, which is the bimodal mafic subtype. We have the Joma, which is the mafic subtype. We have the Stekenjokk, which is bimodal felsic, and we have the Blåsjön, which is a siliciclastic mafic subtype. So, of course, when you're going to do this assessment, you need to have the basic grade tonnage data, and we have too few deposits only in the Caledonides, and we have also included the Appalachian part of the origin. So we have a data set of 208 deposits, which we then forms the basis for the whole assessment. And you can see clearly below here there are differences between the classes. The felsic ones are, for instance, they are the one with the biggest tonnage. The mafic have the highest copper, and also the siliciclastic mafic is quite high in copper. Zinc is you find in the bimodal I don't know what happened here. Somebody took the presentation here. Anyway, to demonstrate the MapWizard, the Gjersvik tract was chosen as an example because it's where we have the most exploration data, the most complete data set. So here you see the Great Tonnage Model tool, where you actually get these data, which forms the basis for the Monte Carlo simulation. We have the undiscovered deposit tools, and we have the expert opinions. You can already see here these data here. And we also have the track delineation tool using the fuzzy logic process. And here's a little bit more example of that, where you actually include the geology, the electromagnetics, magnetometry, and stream sediment data, and use the fuzzy logic process, and actually then find the areas which is then the most favorable for deposits. It's the red ones which is the most favorable. And of course, then we do the Monte Carlo simulation. That's a simulation of 20,000 deposits, and we end up with these grades. You can see the median here and the mean values for the ore and copper and zinc content. And we also went through the economic filter tools, and we can then get an idea what is actually recoverable of the resources in the area. And of course, we did this on all the different tracts. So here you can actually see the result from this. I see that this presentation will be recorded, so actually you can stop it and have a look at this data yourself. But at least you can see that this is a very good tool to actually get an estimate of the undiscovered resources in tract. Even though there are different types of VMS deposits, they give reasonable numbers for what you can discover in the area. Thank you.
Hello, everyone. This is Andreas Bosig from Beak Consultants in Freiburg, Germany. And I now have a brief presentation on the results of our application of the map software to tin skarn deposits in the German Erzgebirge. Yes. Okay. So a brief overview, we created this great tonnage model, then the permissive tracts, estimated undiscovered deposits, and simulated the results all within the map software by GTK. For the great tonnage model, we have the challenge that there is not so much research on tin skarns, and there is a limited number of grade and tonnage data in the literature, as you can see here in these tables. But still, we are able to collect enough data to create a valid grade tonnage model and to confirm that the deposits in our model area conform to the grade tonnage distribution of the worldwide deposits, which tells us that we can actually use this grade tonnage data to estimate undiscovered tonnages or tonnages in the Erzgebirge. This is what the grade tonnage model for the tin skarns looks like, with some data describing the distribution. We can see that tin grades are in the range of 0.2 to maybe 0.8%, and ore tonnages vary widely from less than 1 million tons to almost 100 million tons. For the delineation of the permissive tracts, we use our advangeo prediction software to create a preliminary predictive map with artificial neural networks, including all of the available geologic or geoscientific data in the area. The neural network requires the known deposits as training data and then proceeds to integrate the geologic information, tectonic structures, distance to granite bodies from a regional 2D model, gravimetric, geophysics data, and also stream sediment geology, geochemistry to this predictive map. We then manually edit the permissive tracts by including areas which have the same geology as the favorable areas, because the three-part assessment requires that all areas should be included where there is any chance of finding skarns, even if they're not very favorable, but the existence of skarns is still possible. So with this in mind, we delineate our permissive tracts, which are shown here on the background of our metallogenetic map of the Erzgebirge, which can be found on the website I noted here. So you can look at this in your own time. Then for each of the 7 permissive tracts, we requested 5 experts to provide their estimates on the number of undiscovered deposits at the 90%, 50% and 10% confidence levels. And we see there's general agreement between our experts, and also that some tracts seem to have high potential, like PT2, whereas other tracts appear to have low potential, like PT3 or PT6. This is an expected result because in the delineation of the tracts we included all areas which could potentially contain skarns, even if they are not likely to contain skarns. I cannot, within the time constraints, present results for all 7 tracts, but I have some examples here showing the results for a few tracts and also how to interpret these results in practical terms. On the left-hand side, you can see the probability distribution of undiscovered deposits for tract 1, where we see there is a 49% chance of there being 0 undiscovered deposits, which would mean that further exploration in this tract would run a significant risk of turning up with no results. On the other hand, if you look at permissive tract number 2 on the right-hand side, you see a very different distribution of the simulated number of undiscovered deposits. Here we only have a 6% probability that all deposits have already been discovered. And there's a significant probability of finding 1, 2, or 3, or even 4 undiscovered deposits. Now, if we look at the ore tonnages and the commodity tonnages, it is very interesting to compare the predicted tonnages in the undiscovered deposits with what is already discovered within these permissive tracts. In this permissive tract number 2, we have already 9 known deposits with a cumulative 230 megatons of ore. And if you look here at the result of the Monte Carlo simulation and the distribution of the expected undiscovered ore tonnages, we find that that amount is actually in most cases lower, at slightly below 100 megatons of ore. If we further look at the cumulative plots of the simulated results, we can see that, as I said, the median undiscovered ore tonnage is somewhere around 80 megatons, and the tin content would be estimated at around 120 kilotons. So, on the one hand, with these substantive estimates and the fact that we predict a 6% probability of finding nothing, this tract is very attractive for further exploration. However, it must be seen that the potential which could still be discovered is less than what was already discovered. This means this tract is relatively well explored and most of the resources therein contained are already discovered. If we look at the cumulative plots, we see there's about 15% chance of doubling the tin content, which is not very much, but still the possibility of finding 1 or 2 deposits with 100 kilotons of tin would be economically attractive. To create a full economic assessment, we would also have to consider secondary commodities, which in the case of this skarns would be tungsten and also indium. So to summarize this briefly, we have shown that we can successfully apply the 3-part method with the help of the map software to a type of deposit to which it has not been applied yet. And we can create usable grade tonnage models from relatively sparse data for this not very frequent deposit type. We use our existing advangeo prediction software and its AI algorithms to delineate the permissive tracts. And As I showed, this example of permissive tract 2 was the most prospective tracts, and still there most of the tin resources are already discovered, but there's still a significant and economic attractive potential for further discoveries, particularly so if we would also evaluate the secondary commodities like tungsten, indium, or even fluoride. So those are the results from the Erzgebirge.
I want to show you now the results of our assessment, what we did in epithermal gold in Iceland. And this is somehow different to the other assessments because we are basically in a green field. So far, there is not any single deposit known in Iceland, and therefore there's also quite a limited data available. But I think we did this assessment, and I'm going to show you what was our approach and what are the different input parameters for the MapWizard, and then show you the results. So I just wanted to start with this map, which I took from a very good book chapter that was published a few years ago by my colleague Hjalti Franzen. It basically summarizes the gold, epithermal gold in Iceland. And this map basically shows geological map of Iceland. And there, Hjalti Franzen basically reported there are some observed enrichment in gold in Iceland. And these are basically associated within the fossil systems in a hydrothermal system in Iceland. Yeah, but so far no deposit occurs. Also, there are two prospect area quite close to Reykjavik, the Mokulsá prospect area, which is just a little bit north east of Reykjavik, and the Thomasdalur prospect area, which was recently in the news because there was just a new Canadian company who got interested again and purchased the rights. So there is some enrichment in gold, and so that comes to the impact, to the input parameters. What do we need for our MapWizards? And I think one thing is the descriptive model, and our main work at the Iceland GeoServe is basically related to geothermal energy. But from this geothermal energy, we know quite a lot about the high temperature hydrothermal systems, which are basically actual system where gold is transported, and we know that quite well from several systems that we see that the gold is mobilized at some point, and basically with boiling process we have an enrichment, and we have a very good understanding about this hydrothermal systems. Nevertheless, I say, if you consider a hydrothermal system, this is a multiple component system, and I think this is very well illustrated in this diagram, which shows the different components. So this basically shows that we need energy. We understand the energy quite well. So these are basically the heat source, so the magmatic body. Then we know the fluids. In Iceland, these are basically meteoric fluids. But then it comes already to the point, what are the metal sources? What are the reactions where the gold is released? What are the pathways? We know from observation at active systems that boiling processes cause to the precipitation, but we still not really fully understand the pathways, nor we know the traps. So we still have not the full picture about the ore description, and this is something I want to address then at the last slide again. So what was our approach? So one approach, what we have to use, we have to take a great tonnage model. The big disadvantage is in having not a single deposit, we have no data to calibrate any great tonnage model data. So we basically took this data, which was published just 2 years ago by the USGS, which compiled a global epithermal gold deposits. But just keep in mind this database includes all epithermal gold silver deposits which occur in different geological settings, and none of these deposits is really equivalent to the geological setting what we have here in Iceland. So this is something we need to keep in mind. Then the permissive tract. So I think this is something where we are quite confident. So how did we select it or delineated our permissive tracks? And so first of all, I think you have here on the upper right corner, this is just a geological map of Iceland. And we basically excluded all the active or the recent bedrocks because they are still the deposits are still ongoing to form, and we also have to see that mining most likely will need to be on a subsurface level with unsuitable conditions. So therefore, we only concentrated on the fossil system, so the older bedrock. So this was easily deductible from the geological map, and then we know that gold mineralization occur in central volcanic systems, and this is also quite well-known map by the central volcanoes, which are basically illustrated here by the orange dots. So we have all about 30 to 40 fossil central volcanic systems, which are potential permissive tracks. And for our testing, we basically had a workshop in mid of September, and we selected 3 representative central volcano and estimated the undiscovered deposit and run the MapWizard. And we have here the Breidardalur central volcano, which is a volcanic system, hydrothermal system that was active 10 million years ago in the east, and in the west about 60-70 kilometers north of Reykjavik, the Hafnarfjall central volcano, which is 4 to 5 million years old. And then we have the Caledonides or Stardalur central volcano close to Reykjavik, where we have these 2 prospect areas. I'm going to show you now basically the results of the workshop and the MapWizards. And this is for the Breidardalur. What you see here in the upper right corner, these are basically the estimates of the experts. And this Breidardalur is a central volcano. It has an erosional level about 1,000 meters. And you see that the estimations are quite low from the experts, and hence therefore also the estimated probability function is quite low. Therefore, I think it's not surprising that the simulated cumulative frequency distribution and simulation of the gold and ore is quite low, which you can see here in the table or in the graph. Similar we did for the Hafnarfjall central volcano. You see the estimates. You see the estimates are slightly higher. There is a little bit more exploration data. So exploration data is basically limited soil chemistry data and rock chips data. There's a little bit more data available, also not shows any enrichment, but the big difference to the Breidardalur central volcano is basically that the erosional level is much shallow, which maybe would give a higher chance for ore formation. And you see basically, yeah, it's higher, and also the probability function shown on the right. And then the simulated values show slightly higher values, but still low. And then the last example is basically the Caledonides or Stardalur central volcano. I combined them basically, and you see that the estimation from the experts are significantly higher, and which can be related to the existence of 2 prospects area that they already know there is an enrichment of gold. And you see so some the expert opinion, and also plotted up the estimated probability function. And then here you basically see the cumulative frequency distribution of gold. So basically for this permissive track, we have a 50% probability of having a total 350 kilogram of gold. So this is basically what we did, and basically to conclude, and maybe also to add some recommendation. So we basically applied the MapWizard 3-part assessment tool to green field, and I think it was successful. But I think we have the feeling that we underestimating the gold endowment, and I think we would further recommend to further study the fundamental principle of the gold formation. So because we have the feeling that the descriptive model is incomplete, and I think once we have more information about the model, we most likely can getting a better feeling about possible deposits. And then I think the next thing is, once there is possibly a mining, then the great tonnage model can be calibrated on existing data in Iceland. And that's from my side.
Thank you. Good afternoon, everyone. So if Iceland was greenfield, then I would say that this is greenfield as well. Seafloor massive sulfide assessment, specifically in the Rainbow area, where we have done this. Let's see if I can get my laser pointer. So we are along mid-ocean ridges. This figure from Muller et al. Depicts the mid-Atlantic ridge, and we have analyzed an area that is in the central part of this mid-Atlantic ridge. And along this ridge you have the spreading. The different plates are moving away from each other, and you have fluids that are migrating into the crust. Those fluids are heated due to the heat source that we have down here in the asthenosphere, and it will then starts to leach out the metals that are then focused through this stockwork zone and then emitted then on the ocean floor, forming the massive sulfides and this stockwork zone. And for the Rainbow area in particular, that I will talk a little bit more about, we have then tried to estimate the resource potential on the ocean floor in this area on deposits that are formed basically like this. So narrowing down these deposits then that we had on the previous slides can look like this. This is the tag site, which is the manifestation that has been investigated the most. It has been relatively thoroughly drilled through international projects, and it would contain the mound itself, and also the stockwork beneath contains, according to Grant et al., about 30,000 tons of metals at a grade of 2.8 weight% copper. It's zoned, as we can see here, which is of course also very important to investigate when and if these deposits were to be mined. So you see a map here, an inset here up here where this tag area is, and this tag deposit is then or manifestation is illustrated here. So this is what we are working on: 2,000, 3,000, 4,000 meter water depth. Very difficult to explore for these deposits and very expensive. Well, for the Rainbow area, it's a site. There's a site that is called the Rainbow site. That's an active field. That is a ultramafic site, so ultramafic rocks that this deposit, if I can call it a deposit, is associated with. For this exercise, we have not worked on the ultramafic associated deposits, but we have looked at the resource potential in a basaltic geological setting inside this area that you see here. And inside this area, which is the question, would be whether we have this type of mafic hosted or basalt hosted deposits that are exemplified here again from the tag area. That's the Shinkai and the new mounds and the southern mounds that has been investigated and presented in the Merton et al. Publication from 2019, where they have used a seismic to actually being able to find or at least indicate the geometry of these deposits or manifestations. We don't have any grade information in particular and how the grade variation is with depth, but at least through their investigations, the geometry of the deposits are relatively easy to describe. Interestingly enough, through their results, they document that actually the size of these geometries can be as much as double as the size of what we previously thought. Okay, so we have assessed the rainbow area. That was a workshop in October 7th to 8th, 2020, where we followed the three-part assessment workflow presented by Kalevi. Asked where, so what are the permissive tracts in our mafic setting, how big and how rich are the deposits that we might find there, and how many are there. We have used both the density estimation about how many using global models, and we are also through the workshop or in the workshop asked for the expert opinion. We will focus primarily on the expert opinion in this presentation. So where? Well, Cyril Giuliani, my colleague, co-author on this presentation, did this work where he used the bathymetric data to delineate the tracts, also geophysics, and then based on the bathymetric data, you did structural interpretation and used then backscatter data available in this area to identify firstly the sedimented zones here in yellow, and also the zones associated with ultramafics and also associated to so-called detachment faults, which would be or is a completely different deposit types. Whatever you might find inside these areas here would be something different, and they should then be excluded from the analysis, or you should perform separate analysis for whatever you might find inside these shaded areas. And we have, as I said, also excluded the sedimented terrains here, and then we end up at an area, total area here of 7,600 square kilometers. So that's the basic basis for the further analysis. So what about the grade tonnage within this area? How big might the deposits be? Well, in this work we used work done by Mosier, or we based our work on work done by Mosier et al. In 2009, where they presented these statistics over VMS. So we use analogs, onshore analogs, to describe how big and how rich the deposits are. In our work, in our implementation, we have focused on the Cyprus type deposits and excluded the Kuroko deposits, again, because they are not necessarily from a similar enough geological setting as the one we are working on now. So the number of deposits, the expert opinion, I've included this as kind of a graph. This graph tells us that the experts were 90% sure that the number of deposits was at least from 0 up to 16. They were 10% sure that it could be as much as 100 manifestations, and that's manifestation that potentially could produce the deposits, the size of the deposits that are described by the grade and tonnage curves or models. They were then also 50% sure that there might be 50 for this expert, and interestingly enough, of course, you see that there's great variation where the majority of the experts are not as optimistic, to put it like that compared to these others. And of course, one have to say that we had a 2-day workshop, which might not be enough to kind of bring everybody on the same planet, to put it like that, on geological understanding. So questionable, of course, whether this is an actual reliable resource potential estimate for the rainbow area. I think we should aim for continuing that work. So running the MapWizard software, we get these distributions for the number of deposits. There is a chance of having no deposits, and there are, according to this simulation, no chance of having less than 40, to put more than 40. So sorry, or at least very, very, very slim probability. For the general model that we tried, we have an N10 of 41 deposits, an N50 of 15 deposits, and a 90 of 5 deposits, indicating that this general model is much more optimistic, to put it like that, compared to the experts. So for the results, ore and copper tonnages, these histograms shows, for example, this one shows the ore tonnage in metric tons. This one illustrates the copper tonnage in metric tons. Summed up here in the table, we have a median of 7.9 million tons of ore. With the grade distribution that we have used, we then have 319 kilotons of copper in this area, in this rainbow area, and in the mafic geological setting. I think we have successfully applied the MapWizard, at least from a methodological point of view. The input can always be discussed, and it should be discussed. There's a great variation in number of deposits. We have really and clearly documented that, and there is, of course, uncertainty in the grade tonnage models. We have not applied any economic filter because we don't really know how these deposits potentially could be mined. They are, as I said, on 3,000 to 4,000 meter water depth, and we don't really know how they can and should be mined. We don't know the mineralogical process characteristics of them, whether they can be processed, and then of course we don't know the cost structure of these deposits or the mining of them. So we have for now left the economic filter out. So thank you for the attention. Any questions, please contact myself or Cyril. I see now that Cyril's email have left this slide, but if you contact me, I can of course provide you his email address, and also thank you to EIT RawMaterials for supporting us. Thank you.
All right. Okay, hello everyone. I'm Shen Hong Yang from Oulu Mining School, and Andreas Luspo is a PhD student funded by the MAP project. So I'm going to talk about the first part, the educational activities related to the MAP project, and then Andreas will give a short introduction about his progress on his PhD study. So we tried to find some courses in our course structure in Oulu Mining School, which can this map related materials be delivered to the courses in Oulu Mining School. And we do find a few courses which we can implement this map related materials. So for example, one course is the regional world geology of Skellefteå. As we know, the Skellefteå is the most active region in EU countries for both mining and exploration. So we have one course to dealing with this world geology and exploration activities in Skellefteå. So in this course, we totally have 15 lectures, and we have 2 lectures about map related materials to this course. So for one lecture is about the assessment of undiscovered resources, mainly using some previous modeling results by Galway. We have done a lot of research on this subject and also a lot of publications. So Galway came to Oulu and gave a lecture about this part in 2019. And another lecture is by Vesa Rikkelem from GDK about the mirror perspective modeling. So there's two parts are actually the core of the map software wizard. So at that moment, the wizard is still not available. So we may give this theoretic part to the student. So in 2019, we start to have this course. So Gallivan and Vesa came together to give the lectures in Oulu. And and also my colleagues in Oulu Management School also start to learn these principles of this part. And in this year, these lectures are given mainly by my colleagues and me in Oulu Management School. So in the future, we can still implement this this content into this course, but we can potentially use this the new testing workshop data or results from other partners as some examples to this lectures. Another course, this is a project generation for exploration targeting. This is in collaboration with another EIT funded project, education project, the Explore project. So for this course, there were some other lectures in the beginning to introduce different exploration techniques or method first. And then we have one lecture or part to dealing with how to combine the different exploration data. For example, you have geophysical data, geochemical data, and geological data, how to combine them together as a final output of the prospective modeling result. So we had one lecture in this course, and then after this lecture, the students also can do some exercise using the MPM online tool to do the mirror perspective modeling exercise. For this course, because of the pandemic situation, it's an online course. So we record some video lectures and upload to the website, so the students can learn these materials by themselves and then do some exercise by themselves. And for this content, we some deliverables has been produced this too. And except the lectures, we can also implement this materials as some exercise or practical to some courses. So for example, one course is about magmatic ore deposit. There is one lecture about magmatic nickel copper sulfide deposit type. So after this lecture, we can ask the students to do some perspective modeling using different expression data. Actually, this actually was just similar to the last course we have used. So using the same video lectures recorded and upload to website and give a short instruction so the student can do this learning process and exercise by themselves. And similar exercise has been given to summer school, the Arctic mining summer school. There was one part is about the Arctic mineral resources. So we use a similar exercise in the summer school. There are mainly some bachelor students. So in the future, the map-related materials can be delivered to students via lectures or exercises in different courses as mentioned above. But the difference is in the future, we can use the MapWizard, which is now fellow versions available. So we can ask the students to try their hands to use this MapWizard to do some modeling by themselves. Of course, we need to install this software first in some university computers. Otherwise, it may be difficult for them to install this software. And we can also use some testing data from some partners, from some we have done a lot of different workshops. So if this data are available, we can use as some example or data for the students to do. Okay, that's this educational part. So next part by Andreas will talk about his progress about the PhD study. So Anjas, please, you can talk now.
Hello, can you all hear me?
Yes.
Okay, that's great. So I'm Andreas Nospe from the University of Oulu. I will present some of the steps that were done the last half year. Not just me, also with the research team, we had meetings. So like one of the things were that we evaluated different input parameters and compared different validation tools for the fuzzy logic modeling. And we also looked at the influence of the fuzzy membership function on the final model. And we also used the newly developed ROC2 tool from the GTK to calculate more than 3,000 AUC values for different spread and midpoint values, and to see how this affected the model. In that way, we tried to find the optimal spread and midpoint for different types of input parameters. And yeah, we will also continue with these studies until 2021 and try to get further results from this. Yeah.
Next slide.
Yeah, next slide then. Yeah.
Okay.
So here you can see that we used the WUFI and the ROC tool to validate different input parameters. In our case, different geochemical data, gravity, metamorphic fascias, which we split it up on the lower part. So we mostly looked at the distance to green schist in this case, and also electromagnetic data and volcanic rocks and gold lithographic, prospective gold lithographies and apparent resistivity, aeromagnetics, and so on. And we just looked at the input parameters and evaluated them with the ROC tool and also with the weight of evidence. And then we compared the results and saw and looked if there is if they can be if they are correlating with each other. So basically, we saw that there is a correlation and between the AUC and the contrast that we gain from the weight of evidence, and from that we can it's quite useful to combine these two tools and to have like more than just one validation tool, and then you can make a validation and look which input parameters might be useful for the models and which one are not. And that's what you can also see here, that there's like different values with different qualities. Yeah, we can look at the next then. Yeah, okay. We also looked at the influence of the spread and the midpoint on the fuzzy overlay, where we can, in this case, we looked at the distance to green schist, but we can also, like, dependent on which parameters we use, if you look at the small or the large function, then these results will look different if dependent on which spread and which midpoint we are selecting. Yeah, we can go to the next slide. Okay. We also looked at the results of the Fuzzy Rock 2 tool to see the influence of various settings for the spread and midpoint. And well, we can look, and yeah, we looked just at what value do we have, which AUC value, and then which input parameters were used, and then to see which has a positive or negative influence. And when we look at the next slide, then yeah, here we marked them, and in this case, like, we looked at what parameters have a positive influence, and then we can see that these parameters, which have a positive influence depending on which input parameter we look at, provide us better AUC values for our models. And yeah, we're still on that, and we try to figure out how the spread and the midpoint affect the models, and obviously there is a correlation depending on whether we have the small or the large function, or like where the majority of the values in which category they're ranking, and then dependent on this we need to select different settings and to gain better or worse AUC values for the final model. And that is something we will continue also in the next year then.
People have talked about the TDK coding this and TDK coding that, and that's fine. We have coded the MapWizard software, but have to admit, or have to give credit to the US Geological Survey. Very many of the important tools are based on USGS code, and USGS has a long history in the field of undiscovered resources estimation, because the whole three-part method was developed by USGS scientists in the 1970s, 1980s, and we wouldn't be really here without that code existing already. So we have put it all together and wrapped it up and then put it in the same package so that we can kind of produce a software that runs through the whole assessment process. But several of the individual tools are based on USGS code, and without that code would have taken well, several times more time to get here where we now are. So that I just wanted to say that this has been very important. The USGS cooperation has been very important, and we have really enjoyed that. Mark Mihalaski was the he was with the USGS at the time, and it was very good working relationship with him and the USGS team. So thanks for USGS also for providing that code for us. And well, as I said earlier, MapWizard freeware is now on GitHub. The address is here, but it's also very easy to just, if you just search, you Google GitHub and MapWizard, you can get to the right page immediately, and the installation package is there, and you can download it, and it's free of charge. And it comes with the source code, technical documentation, user manual, method and data guide that guys you kind of give some kind of guidance of the three-part method and what kind of data is input and how it should be treated, and some example, very simple example data to test the various tools also. So I urge, I suggest you try the tool, see what it can do for you, and if you're interested, you can contact us and get more information. And also be aware, or if you're interested in doing some commercial work with the tool, maybe the Beak version, the commercial version, might work better for you. At least it has more advanced mineral prospectivity mapping tools available in that version. So that's my final kind of statement. If you want to ask some questions now it's a good time to ask questions and or make comments on and give general discussion. There's time for that now. So please raise your hands, and Rune Berg Edland Larsen has already raised his hand, so please go ahead.
Yeah, thank you very much. I mean, and particularly thank you for an incredibly interesting new software opportunity. So not to waste too much time, I will get right to my first question, and it is probably to Tobias from Iceland, because I mean it is about some of the abilities of this new software. I mean, you talked about the transport of gold by meteoric water. Which makes lots of sense, although, I mean, I suppose that some of the older deposits could even have been under seawater. But I just wonder, could you model, for example, the dominant complexing agent? I mean, whether that would be a bisulfite or chlorine, which would make a huge difference from the ore forming potential. Is that a parameter that somehow can fit into to the software?
So thanks for the question. I think this is quite important to understand the process. I think it does. It's important to know, but I think it does not really go into your into the software. But I think this knowledge about understanding the transport mechanism, the complexing, will help the experts to estimate the undiscovered deposits.
Yeah, thanks. Just one more question. I mean, and then I shall bug off. You are considering mostly gold, but your source rock would contain also, a bit of platinum, a bit of palladium, even some copper. If you or quite a lot of copper, of course, if you have the right complexing agent again.
I'm not sure of palladium. I have never seen any study. I think there was some exploration studies in the 70s which looked up for copper exploration. I think so far there has not any copper enrichment found in Iceland. So I think the only thing it's possible metal is basically gold, and yeah. But I think this brings up the next thing. I think you for sure also need to consider, okay, there's some systems are meteoric and some are saline. So I think some of the active system nowadays, considering the geothermal system and the Reykjanes Peninsula, they are for sure seawater dominated systems. And, but I think this is you need to be careful comparing them with meteoric water system. I think the complexing, it's not, there are differences. Also, I think what we learn from these systems, that the boiling process seems to be the dominant mechanism basically for the precipitation. But I think there's very limited known so far. I think that for sure can be done more fundamental studies.
Okay, thank you.
Yeah.
Okay, Graham, your hand was up. Mark is next.
Hi, Kalevi. This is Graham Lederer from the USGS. So I just wanted to thank you for putting together this fantastic workshop and debuting the software tool. I think it's a wonderful addition to the tools available to us. And also wanted to thank GTK for their commitment to open source software, which leads me to my question is, what is the plan for stewardship of the software? And, if there are, for example, updates that are made, say, to some of the underlying USGS code, how can that be contributed to, say, like future iterations or versions and that sort of thing?
Yeah, that's a good question. As always with the project-funded software, it will be open source. It will be kind of we will hope there will be some kind of a user community will build around this software so that there could be some contribution from that. We are, I'll be still available at least until the end of next year. So basically, we might try to do some upgrading, some maintenance at the survey, but that's pretty limited unless we get some funding outside of it. But yeah, it's a good question. It's a bit of a problem with software that is coded in a project. So how to maintain it afterwards. Yeah, unfortunately, I can't promise you a certainty, but at least for and again, yeah, I noticed Andreas' hand. Beak will continue to at least offer the commercial version, and maybe we haven't discussed this through yet so thoroughly, but maybe Beak can also provide some support for the commercial the freeware version. That's an option too.
Great. I look forward to participating in that community. So thanks.
You're welcome. Yeah, you're welcome. It's on GitHub now. Go ahead. Mark, hi.
Hi, everybody. Can you hear me?
Yeah.
This is really impressive, and I'm happy to say hello to my colleagues there, Kalevi, Vesa, Andreas and some USGS colleagues, Graham, and looks like Jane is on the line. This is a very impressive thing that you've put together here. My only regret is that I was not able to help finish things off when we started, and to continue my involvement. It's really impressive the packaging that you guys have done of these various components, and as well as the added functionality in things such as the track delineation. I think the idea of being able to have MPM as well as standard binary tracks that we use in the regular three-part assessment method is a great thing. I was really impressed to see in Beak's version the thresholding tool, where you can take a raster and then threshold particular values above and below to produce basically a polygon that is more what would be considered a traditional track. And there certainly is a role for both those kinds of conceptualizations of a track, particularly with respect to estimates of undiscovered deposits. In the past, we've found that having an MPM track with multiple levels can kind of get confusing as far as perhaps coming up with numbers of undiscovered deposits. But if you minimize those levels, and it becomes more of a tool. But at the same time, if you do have all those levels and the various indicators of where the favorability is higher, that also helps with the number of undiscovered deposit estimations by the experts. So I think that's a nice little addition to have that threshold tool in there as well. And what's interesting about all the examples is, even with the refinements that you guys have done, some of the usual challenges are still there. Producing a good grade and tonnage model, also defining what is a deposit. I really liked the undersea massive sulfide mid-Atlantic ridge example, as in not so much looking for deposits, but rather looking for manifestations. And so then understanding that there's a difference between a manifestation and a deposit, but at the same time, yes, indeed, you can make estimates with respect to those things as well, but understanding that that they may not be deposits in the traditional sense. So again, congrats to all you guys and gals pulling this all together. It looks like a really wonderful tool, and I really hope that the USGS and GTK continue their collaboration on this. And then if one of you folks begins to work with uranium, you must let me know, because there may be opportunities to get involved with expert workshops and technical training sessions and stuff here at the International Atomic Energy Agency in Vienna and elsewhere. So that's just my little plug for where I am now. But at any rate, congrats and well done, guys. Very, very nice.
Thanks, Mark. Yeah, it's kind of a, yeah, well, also our, at least in the freeware version, the map mineral prospective modeling tools are rather simple, but they are there, and that's kind of it makes people think that they are part of the process, so at least they have to think about whether to use this or not, and maybe it could be useful to try to delineate the tracks with MPM also. Yeah. So I think just putting it in there is already important.
Yeah, no, most certainly, because what it does is it spurs and inspires different approaches to things, and certainly we've been trying for years to merge the two. They are complementary methods, and as often as possible should work together. I totally agree that was a very, very good idea.
Yeah, and mind you, the freeware version also has a kind of a raster threshold that can be used to cut mask rasters to try different threshold values to make proto tracks. Yeah. Anybody else? Anything? All right, Jane.
Yes, hello everybody. This is an amazing presentation. Thank you all. My question is, and I think it was for Andreas, in the talk about scarns, when you talked about tin scarns and the fact that in order to consider the economics, we need to think about things like indium. That's been a real challenge for us. And how do we deal with these byproduct critical minerals and trying to get them into a grade tonnage model? So I just want to throw this out there that if anybody is working on that, it would be really interesting to know. One of the problems we have is no availability of reliable data for these things. So if anybody's working on that, we'd love to hear about it. Thank you.
So everybody keep that in mind. Anybody else?
And Andreas, do we have some data from the Erzgebirge about indium? Are you still there?
Yes, I'm here. We have some data from the Erzgebirge, but it is by far not enough to create a great tonnage model for indium in skarns. No. So that's an open question. We have data for tungsten. We could create great tonnage models for tungsten skarns, but not yet for indium.
I mean, if you have some indium data, somebody else somewhere else might have more indium data, and you could kind of try to combine all that together to get kind of a global great tonnage model.
Yeah, we would need to look into this more, but I agree this is definitely an interesting avenue to explore.
Yeah, anybody else? Anything? Any further questions, comments? So silence. We are nearing the finishing time anyway, so if there's nothing else, I have to thank everybody for joining us, and we enjoyed this session and all the questions and comments and presentations. Thank you, everybody. Thank you for the team, MAP team, for doing this and making all this together. Well, MapWizard is now out. The software is out, and we hope you can test it and see for yourselves what it can do for you.